Hi my students, today we are going to study power and efficiency. At the end of this lesson, you will know what is meant by power, how can we calculate power, what is meant by efficiency, and how can we calculate efficiency. Power. Power is defined as the rate of doing work or the rate at which energy transferred. So power depends on the time needed for doing a work. Suppose we have a small engine can do just as much work as big engine, but small engine take longer time to do it, and the biggest engine can do work at faster rate. The rate at which work is done is called power. So the small engine has small power, but big engine has higher power. Power defined as the rate of doing work. So power can be calculated by work over time or energy over time. The formula of power is work divided by time or energy divided by time. The symbol of power is P capital, and its unit is watt or joule per second. Watt equivalent to joule per second. There are another formulas for power. First one, we said before that work equal force times distance. So in the formula of work equal divided by time, we will use force times distance instead of work. So power will equal force times distance divided by time. Also we know that distance over time equals speed. So instead of d over t, we can write power equal F times V. So we have three formulas can be used to calculate power, depending on the givens in the questions. First one, power equal work over time or energy over time. Second one, force times distance over time. Third one, force times velocity. Now we are going to solve some questions related to power. First question. A crane is capable of doing 1.50 times 10 power 5 joules of work in 10 seconds. What is the power of the crane? In this case, we want to calculate power, and we have work and time, so we'll use the first formula, which is P equal W over T. We have W 1.50 times 10 power 5 divided by 10. So power equal 15,000 watt, or when we want to convert from watt to kilowatt, we will divide it over 1000. So power equal 15 kilowatt. Second question. Cyclist and her bike have a mass of 60 kilogram. She is able to cycle up a hill that changes her altitude by 400 meters in 1 minute. Assume no friction. How much work does she do against gravity in climbing the hill? How much power is she able to generate? First question, we want to calculate work. To calculate work, we should have force and distance. But in this question, we haven't force. We have mass of the cyclist and her bike. We have distance. But to calculate work, what will we do? To calculate work, we will use the relation between work and change in potential energy. Total work done equal change in potential energy. So W equal mgh final minus mgh initial. mgh final, m equal 60, g equal 10 or 9.81 cm times height, which equal 400. minus 0, which is initial potential energy. So total work done equal 2.35 times 10 power 5 joules. Second question, to calculate power. Power equal work over time. We calculated work in the first question, so we'll use the result. So work 2.35 times 10 power 5 divided by 60. Why we use 60 seconds? Because we should use the quantity in SI units. He give us the time in minutes, but we should convert it into seconds. So power will equal 3.92 times 10 power 3 watts. Efficiency. Engines and motors do work by making things move. Petrol and diesel engines spend the energy stored in their fuel. Electric motors spend energy supplied by battery or generator. Also, human body is a form of engine. It spends the energy stored in food. But engines does useful work with some of the energy supplied to it, but the rest is wasted as thermal energy. So all or not all systems are closed systems. There are some of energy supplied, waste or lost in the form of thermal energy. The efficiency of an engine calculated by useful energy output divided by total energy input. The efficiency of a machine is a ratio of the useful power produced or power output to power supplied to the machine, which is input power. So efficiency, output power divided by input power times 100%. If energy input and removal occur at the same time, efficiency may also be expressed in the term of ratio of output energy to input energy. So efficiency equal output energy divided by input energy times 100%. No unit for efficiency. Efficiency equal work over work, output over input, or output energy over input energy. So no unit for efficiency. The first question related to efficiency. A rocket has 3.50 times 10 power 3 joules of chemical potential energy. The stored chemical energy is transformed into gravitational potential energy when it is launched. What is the efficiency of the rocket's transformation of energy if the 0.5 kilogram rocket travels 1 times 10 power 2 meter? Where does the lost energy go? In this case, we will start with the second part of the question. Where is the energy lost? Most of energy is lost, meaning it transforms into thermal or heat energy and light energy instead of gravitational potential energy. So energy lost in the form of thermal energy or light. After that, we want to calculate efficiency. Efficiency equal output energy divided by input energy. In this question, we haven't output energy, so we will start to calculate it. Output energy in the form of gravitational potential energy, which is mgh. So mgh divided by 3500 times 100%. So efficiency equal 14%. This is the end of our lesson. Try to solve your homework that uploaded on Moodle.